Welcome to the June 2014 GCSE Maths Past Paper 1 walkthrough. This is a past paper given to you before Christmas, and it's the non-calculator paper, the first of the two that you'll take in June. As usual, on the YouTube channel, there are shortcuts that take you straight to questions that you're interested in, rather than you having to scroll through the video. Question 1a. Write these numbers in order of size. Start with the smallest number. So this question is about sorting positive numbers. Starting with the smallest, our smallest number is 25, then 52, then 55, then 102, and then finally 120. And that's worth 1 mark if they're in the correct order. The next question is asking you to arrange numbers in order of size, starting again with the smallest, but this time they've introduced negative numbers. So do you understand the negative numbers on the number line? So -5 is the smallest number that we have in our list, with -2 next, then 0, then it would be 3 and 6. So the order is -5, -2, 0, 3, then 6. Question 1 part C wants us to order numbers again, but this time they've given us decimals to order, and again starting with the smallest number. So do we understand positional values of decimals? Well, one of the easiest ways to do this is make all of the decimal numbers the same length. So they're all 3 digits long. So if I make them all 3 digits, you can see clearly that this is 60, this would be 600, 603, 630, and 633. So it's easier to arrange and see that 0.06 was my smallest number before I put that third digit in. 0.6 would be the next, 0.603 next, 0.630, and then finally 0.633. So they are the decimal numbers in order of size, with the smallest first. Again, worth 1 mark. Question 2. Here is a fair 6-sided spinner. Ryan is going to spin the spinner once. Which colour is the spinner most likely to land on? Well, the most likely one is the one that we have most of. So we have 1, 2, 3 red, 2 blue, and 1 white. So the most likely colour is red. Choose the word that best describes the probability that the spinner will land on white. Well, there's only 1 white out of 6 possible options. So it's going to be unlikely. So unlikely. And that's 1 mark. Choose the word that best describes the probability that the spinner will land on green. Well, as there are no greens on the spinner, that's going to be impossible. Again, 1 mark. Question 3. The table shows some information about the number of medals won by Great Britain in the 2012 Olympic Games and in the 2012 Paralympic Games. Great Britain won more medals in total in the Paralympics than it did in the Olympic Games. How many more medals in total? So there's several ways to do this. You can either work out the difference between each of the medals and add up those differences, or add all of the medals for the Olympic Games, add all of the medals for the Paralympics, and take one from the other. Whichever way you want to do it is fine. So let's add up all of our medals. Using the column method, 29 plus 17 plus 19. 9 and 9 is 18 and 5 is 25. So put down the 5, carry the 2. 2, 4, 5, 6. So 65 was the total of Olympic game medals. The Paralympic medals were 34, 43, and again 43. Using the column method, 4 and 3 is 7, and another 3 is 10. So the 0 goes down and the 1 is carried. 4 and 3 is 7, and then another 4 is 11, plus the 1 we carried is 12. So we had 120 Paralympic game medals. Finally, we take one from the other to work out how many more medals we won at the Paralympics. So column method, 5 can't take away from 0, so we borrow 1 from the next column. 5 from 10 is 5, 6 from 5 doesn't go, so we borrow 1, and 6 from 11 is 5. So the difference between the Olympics and the Paralympics was 55 medals for 3 marks. So 55 is 1 mark, and the working out for each of the Olympics and Paralympics are also 1 mark each. Here are the first 4 terms of a number sequence, 3, 7, 11 and 15. Write down the next term of this sequence. So we need to work out the rule. So to get from 3 to 7, we're adding 4. To get from 7 to 11, we're adding 4. So to continue our sequence, 15 plus 4 would give us 19, and that's worth 1 mark. The 50th term of the sequence is 199. Write down the 51st term. So to get the next term in the sequence, we simply add 4. So 199 plus 4 is 203. And that is worth 1 mark. Part C, the number 372 is not a term of this sequence. Explain why. Well, when you look at the sequence here and the other numbers we've seen in the sequence, every number in the sequence is odd. So every number is odd. 372 is, of course, even. And that's worth 1 mark. Question 5. Farah recorded the minimum temperatures in degrees C on each of the 7 days in January. Here are her results. Part A. Work out the difference between the temperature on Tuesday and the temperature on Wednesday. So the temperature Tuesday is -1 and the temperature on Wednesday is +2. So thinking about our number line so we don't make any mistakes, -1 is here and +2 is there. So the difference in temperature is 1, 2, 3 degrees. So 3 degrees C is worth 1 mark. Work out the mean temperature Farah recorded. So the mean of a number, so here we're doing a bit of statistics, is the total of the numbers divided by the number of numbers. Well, the number of numbers is quite easy. As we go 1, 2, 3, 4, 5, 6, 7 days of the week, we know the denominator is 7. The tricky bit of this question is adding up negative and positive numbers for the day's temperatures. The easiest way to add up the temperatures are to take the negative numbers, so -2 plus -1 plus -3, and you know on the number line that when I'm at -2 and I add -1, I'm going that way, and when I add -3, I'm still going that way, so that would give us -6. Add the positive numbers, so we can ignore Thursday as it's 0. So we have 2 degrees for Wednesday, 4 degrees for Saturday, and 7 degrees for Sunday. So 2 plus 4 is 6, plus 7 is 13. So what we have is 13 positive, take away 6 negative, and that gives us 7 degrees. So if we put the 7 as our total here, then our mean is 7 divided by 7, which is 1 degree C. So our answer for 2 marks is 1 degree C. So 1 mark for the correct answer on the answer line and 1 mark for a correct calculation for the mean. Question 6. Here is part of a train timetable from Newcastle to London. The train leaves at 05:56. What time should this train get to London? So this is a question of reading a table. So the train we're interested in leaves Newcastle at 05:56 and we're going to London, so it arrives in London at 09:08. Part B. Matthew gets the station in Darlington at 06:45 and he wants to catch the next train to York. So if he gets to Darlington at 06:45, he's missed this train, so he has to catch the Darlington 0700 train. How many minutes should he have to wait for this train? So if he arrives at 6:45 and he needs to wait until 7 o'clock, then that's a 15-minute wait. 1 mark. Part C. A train leaves Peterborough at 09:48. How many minutes should this train take to get from Peterborough to London? Well, we know it arrives at London at 10:45, so how many minutes from 09:48 to 10:45? If we add 1 hour to 09:48, it would be 10:48, which would be 3 minutes later than we actually arrive. So if I take off 3 minutes, I actually arrive at the right time. So an hour is 60 minutes, take away the 3 minutes that we need to adjust, and we end up with a time of 57 minutes for the journey. So 57 minutes, correct answer on the answer line is 1 mark. And like I say, there are lots of ways of doing these calculations. Question 7. A petrol tank holds 48 litres of petrol when it's full. So on our dial, full is 48 litres. The scale shows information about how much petrol there is in the petrol tank. Work out the number of litres of petrol in the petrol tank at the moment. So if 48 is when it's full, if we halve it, then we have 24 litres at the halfway point. The indicator is a half of a half, in other words, a quarter. So 24 divided by 2 tells us that the indicator is pointing at 12 litres. So we have 12 litres of fuel. 1 mark for 12 litres on the answer line, and another mark for some working out on how you got the answer. The second part, the total weight of 3 boxes is shown on this weight scale. Each box has the same weight. Work out the weight of the box. So this is a question on scales and doing a bit of division. Now, to work out what each of the smaller units are on our scale, look at the larger gap. So from 0 to 200 is a gap of 200. Then we have 1, 2, 3, 4 steps that fill that gap. So 200 divided by 4 is 50. So each small step on our scale is 50. So our indicator here is looking at 650, 700, 750. So the scale reading is 750. So 750 grams is the weight, and we have 3 identical boxes. We need to show the examiner that we can divide 750 by 3. So let's do that using short division. 3 into 750, 3 goes into 7 twice, remainder 1. 3 goes into 15 5 times, remainder 0. And 3 goes into 0, not at all. So 750 divided by 3 is 250 grams. So 250 is the answer for 1 mark, and some working out on the scale and the division are the other 2 marks that will give you 3 marks for that part of the question. Question 8. Here is a 5-sided polygon on a dotted centimetre grid. Write down the mathematical name for a 5-sided polygon. Well, for any 5-sided polygon, it is a pentagon, much like the building in the United States. The one we're looking at here is what we would call an irregular pentagon, because all of the sides are different lengths. On the diagram, mark with arrows a pair of parallel lines. Well, the easiest ones are the horizontal lines. They are parallel. In other words, they go in the same direction and they'll never meet. Another pair of parallel lines that some of you spotted were these lines, and that's fine. You would have also got the mark for that pair of parallel lines. Finally, part C, what type of angle is marked with an X? So X is what we call an acute angle. It's less than 90 degrees and more than 0. And again, that's 1 mark for the word acute. Part 8D wants us to work out the area of our 5-sided polygon. And this is worth 2 marks. Well, when you have these centimetre grids, the easiest way to do it is count the number of squares that make up the shape. So looking at whole squares, there are 1, 2, 3, 4, 5, 6, 7, 8 whole squares. That leaves 1, 2, 3, 4 halves of a square. So 4 halves are 2. So our 8 full squares plus our 2 part squares gives us an area of 10 centimetres squared. So 10 centimetres squared for the 2 marks. Question 9. The table shows information about the average daily hours of sunshine in Mallorca and Crete for each of 5 months. Simon wants to compare this information. So on the grid, draw a suitable diagram or chart. So when you're comparing 2 sets of information, the best format for this is a dual bar chart. Where we put one set of information against the other side by side. So for example, April will compare 9 and 6 hours of sunshine. Now when you draw a dual bar chart, you need to work out the scales to make the most of the paper. So on the vertical scale on the left hand side, we need to plot our biggest number, which is 13. So if we do a quick check, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Each of these squares will represent 1 hour of sunshine. So we should label the axis and put our scale on that axis. So if 0's here, 1, 2, 3, 4. This is 5 hours, 6, 7, 8, 9. This would be 10 hours, 11, 12, 13, 14. And that would be 15 hours of sunshine. So don't forget to label the axis. We also need to think about how we're going to organise our bars. Now, if you're comparing 2 bits of information, for example, our 9 hours and our 6 hours, you also need to leave a gap between April and May. So for each of our months, we have to have 3 bars, 1 for Mallorca, 1 for Crete, and 1 to give us our space. So we need 1, 2, 3, 4, 5 months with 3 bars for each month. So we need at least 15 bars across the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Almost perfect if we use one of these bars for each of our bars on our bar chart. Again, we need to label the axis and start planning where we're going to draw the information. So if we leave a gap for our first bar and the axis, and we make the first area, our first 2 bars for April, April will take these 2 bars here. So let's draw in April. So when you do it in the exam, you're going to use a pencil. So from 9, you're going to draw a line down to the bottom. A line across at 9, and then that's your bar for Mallorca. Now, if you're going to plot Crete and it goes up to 6, it would go across here and there. Now, we've got an issue, so one of the most important things of a dual bar chart is the key, so we can distinguish Mallorca from Crete. Now, one of the quickest ways to distinguish the 2 bars and not wasting time shading in the exam is to just draw a crosshatch on one of your 2 bars. So we've decided Mallorca's going to have the crosshatch, so within seconds in the exam we can quickly do that to show which of our 2 bars is Mallorca. Now we need to plot the rest of our bars for the months, so I'll do this quickly for you. Remembering to leave a gap between April and May, these 2 bars here will represent May. The important thing to remember about the bar chart, dual bar chart, is to leave this gap between each of the bars. If there's no gap, then it's not a dual bar chart. It becomes a different display called a histogram. The final thing our bar chart needs is a title. So at the top, put a title. And that completes the bar chart. So let's have a look at how the 4 marks are allocated. The correct format, so you have a title, axis labels, and labels and scales that make the most of the paper, is 1 mark. Bars that go up to the correct heights, 2 marks, 1 mark for your key, and then a final mark for leaving the gaps between the bars. So they're the 4 marks for question 9. Question 10. You can use these rules to change temperature from degrees C to degrees F. So approximate rule is multiply degrees C by 2 and then add 30. So multiply by 2 and then add 30. The exact rule is multiply by 1.8 and then add 32. So Amy uses the approximate rule to change 20 degrees C into F, and Dan uses the exact rule to change the same value, 20 degrees C, to F. Work out the difference between Amy's result and Dan's result. So this is a test of basic number manipulation with the approximate rule and your ability to manipulate decimals with the exact rule. So let's quickly look at Amy's then. We put in 20 into our function machine. We put in 20. We multiply it by 2 and we end up with 40. And then we add the 30, so 70 comes out of the other side. So when we put 20 in, degrees C, we get 70 degrees F for Amy. For Dan, his rule requires a bit more calculation as it has a decimal. So we put 20 in, and the first thing we have to do is multiply it by 1.8. So for Dan, we need to multiply 1.8 by 20. Now there's an easy way to do this. When you're multiplying decimals, you can move the decimal point and note you've moved it one place to the right. So it becomes 18 times 20. Now when you're multiplying by anything with a 0 on, just do 18 times 2 and then stick the 0 back on later. So for example, 18 times 2 is 36 and then add the 0. So 18 times 20 is 360, but don't forget to move your decimal point back. So 1.8 times 20 is 36. So at the first stage, Dan gets 36, and then he has to add another 32. So 36 plus 32 would give us 68 degrees F for Dan. So when Dan puts 20 degrees C in, he gets 68 degrees F out. Now the question is asking for the difference between Amy's result and Dan's. So 70 minus 68 is there's 2 degrees difference. So 1 mark for the 2 degrees, 1 mark for the difference calculation, and 1 mark each for Amy's calculation and Dan's calculation. Part B. Jade uses the approximate rule to change degrees C to degrees F, and the result is 110 degrees F. What degrees C temperature did Jade change to F? Well, in order to change degrees C to F, we have to multiply by 2 and add 30 to get degrees F, and that's using the approximate rule. Now, because we've been given degrees F, we're going to go backwards on our little function machine. So instead of adding 30 when you go back the way, you do the opposite. Instead of multiplying by 2, we divide by 2. So when we put 110 in, the first thing we do is 110 take away 30 gives us 80. So we're going to stick 80 in, and then the next thing we're going to do is divide it by 2 so that 40 is the degrees C that we need. So 40 degrees C would get you 1 mark, and the 2 calculations done correctly to get you to the 40 will be your other 2 marks for this question. Question 11. What fraction of this shape is shaded? Give your answer in its simplest form. Well, the shape is 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5, 6. So 5 by 6 means there are 30 squares in total. The number of shaded squares is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 are shaded, so 14 over 30 is the fractions that's shaded. However, it's asking for it in simplest form. In other words, can we divide the numerator and the denominator by the same number? Well, yes, we can. We can divide both by 2. So 14 divided by 2 is 7. 30 divided by 2 is 15. Can it be simplified again? Well, no, because 7 is a prime number and it doesn't go into 15. So we can stop our calculation there. So in its simplest form, it's 17/15 are shaded. Write down the order of rotational symmetry of this shape. Write down the order of rotational symmetry of this shape. So the order of rotational symmetry is sticking a pin in the center and spinning it round and seeing how many times it maps onto itself. Well, if I go round 90 degrees, this will not map onto there because I have 3 squares and 2 squares. However, if I rotate it 180 degrees, these two map onto these two, these three map onto these three, and this one will map onto this one. So that's our first order of rotation, and then when we complete our 360 degrees, it maps on again. So rotational symmetry of the shape is 2. Part C. On the shape below, shade as few squares as possible so that the dotted line is a line of symmetry. So on a line of symmetry, what's on one side needs to be reflected onto the other. So providing there is a square the same distance from our line of reflection, so 1, 2, 3 squares away, 1, 2, 3, these two match up. This one, however, does not match up with this one, so we need to shade it in. This one needs to match with this one, so it needs to be shaded in. This one here needs to match up with this one, so it needs to be shaded. This one matches with this one matches with this one. This one here needs to match with this one here, so it needs to be shaded. This one matches with this one needs to match with this one, so it needs to be shaded. And then finally, this one needs to match with this one, so we need to shade this one in. So that's all our shaded squares in symmetry. And that's worth 2 marks. Question 12 is about algebra. The first part is to simplify a times c times 3. So in algebra, when you're multiplying, you can put the numbers and letters together. However, there is an order. Numbers need to come first, so we need 3, then the letters in alphabetical order, A and then C. So A times C times 3 would be 3AC for the 1 mark, and they have to be in that order. Simplify P times P times P. Well, P times P would be P squared, and then because we're multiplying it by P again, it would be P cubed. So P cubed is the same as P times P times P. Part C, simplify 5x minus 4y plus 3x minus 3y. Now the trick with these is to circle the like terms. So 5x is one term, and then I've got to add another 3x's. So 5x's add 3x's is 8x's. Now for the y's, I've got minus 4y, and then I've got to minus another 3y. So if you think of your number line, you're starting at minus 4, and you're going 3 in that direction. So minus 4 minus 3 would give you minus 7. So the outcome of these two is minus 7y. So it's 8x minus 7y. And that's worth 2 marks. Question 13. 5,600 copies of the Village Advertiser are printed each week. Write the number 5,600 in words. So 5,600 is worth 1 mark. People have to pay to have an advert in the Village Advertiser. Each advert is in the shape of a rectangle, and the table gives you the cost of each of the shapes. A size 2 advert is a 90mm by 35mm rectangle. In the space below, draw a 90 by 35mm rectangle. So what you need to do is, using the ruler that you brought to the exam, is put the ruler on the paper and draw a horizontal line that is 9 centimeters long. Draw a line at right angles that is 35mm long. Then all you need to do is draw another 35mm line at the other end, making sure it's at right angles. and then join the two open ends. And there we have our rectangle 90 millimeters by 35 millimeters. So 9 centimeters by 3.5 centimeters on our ruler. Next, David has this advert in the Village Advertiser for 2 weeks. The advert is drawn accurately. What is the total cost of the advert for the 2 weeks? So we need to measure the two sides of the advert. So when we do that in millimeters, .45 millimeters wide by 27 millimeters. So when we go back to our chart, 45 by 27, 44 by 27 is £6.50. It's a size 1 advert. So a size 1 advert is £6.50 for 2 weeks, which is £13. So £13 is worth 1 mark. 1 for your calculation for the 2 weeks and 1 mark for measuring within a reasonable accuracy the width and height of the advert. Raja wants to have a size 2 advert in the Village Advertiser for 8 weeks. He has £100 to spend. Show that Raja does not have enough money to pay for the advert for 8 weeks. You must show your working out. So a size 2 advert is £13.50. So we have £13.50 and he wants to run it for 8 weeks. So there's many ways to do this multiplication. The easiest way would be to convert it into a whole number by moving the decimal place 2 places and multiply it by 8. 8 times 0 is 0. 8 times 5 is 40, so 0 carry the 4. 8 times 3 is 24, plus the 4 is 28. 8 times 1 is 8, plus the 2 is 10. So it would be 10,800 pence. So to get it back into pounds, move the decimal point 2 places. So he needs £108. So to show that he hasn't got enough, he needs 108. He's only got 100. He's £8 short. And that's worth 2 marks. Question 14. A charity appeal is made for some money and the charity puts information on a poster. So that a hunger appeal has £3 for 5 meals or £100 for lunches for 80 school children for 5 days. The first part says that £3 will buy 5 meals for 1 person. Work out the cost of one of the meals. Give your answer in pence. So we've got £3 is for 5 meals. So that's the cost against the number of meals. And we're trying to work out how much 1 meal costs. So to go from 5 to 1, and this is a ratio question, you divide by 5. So £3 is the same as 300 pence. So when we divide 300 by 5, it will tell us how much 1 meal costs. So 300 divided by the 5. 5 doesn't go into 3, 0, carry the 3. 5 goes into 36 times, nothing to carry over. 5 into 0 doesn't go. So 1 meal costs 60 pence. And that's worth 2 marks. 60 pence on the answer line is 1 mark, and some kind of working out to show how you've divided the £3 by 5. Part B tells us that £100 will buy lunches for 80 school children for 5 days. Work out the cost of buying lunch for one school child for one day. Well, again, it's similar to ratios where the £100 will buy us 5 days of meals. So to work out the cost of one day of meals, we divide by 5. So 100 divided by 5 would give us 20. So it's £20 per day for the meals. Now the £20 is for 80 school children, and we want to know what one meal costs. So we've got to divide both sides by 80. Now, rather than £20, it's going to break down into pence. So £20 is 2,000 pence, and we're going to divide it by 80. Now, when you're doing division, you can cancel those zeros off and still get the same numbers. So in effect, we're going to divide 200 by 8, and we need some system to show that. So let's use short division. I've got 200, and I'm going to divide it by 8. 8 doesn't divide into 2, carry the 2. 8 goes into 20 twice, remainder 4. 8 goes into 40 5 times. So 200 divided by 8 gives us 25 pence per lunchtime meal. So 1 mark for 25 pence and 1 mark each for showing how much it costs per day and then how much it costs per meal. Question 15, and here we have a matchbox which is 5 by 8 by 2 centimeters and a carton that is 20 by 40 by 20 centimeters. The carton is completely filled with matchboxes. Work out the number of matchboxes in the carton. And there are several ways for doing this. One of the easiest ways is to match up the dimensions and see how many matchboxes go into each dimension of the carton. So for example, if we look at the depth of the matchbox, it's 5 centimeters, and the depth of the carton, it's 20 centimeters. So when we divide 20 by 5, we know that we get 4 matchboxes along that dimension. And we do this with each of our dimensions. If we now look at the width of our matchbox, it's 8 centimeters, and the width of our carton is 40 centimeters. So 40 divided by 8 is 5. So we would get 5 matchboxes across the front of our carton. And finally, the height of our matchbox is 2 centimeters. The height of our carton is 20 centimeters. So 20 divided by 2 tells us we'd get 10 matchboxes stacked on top of each other in our carton. So now all we need to do to find out the total number of matchboxes is multiply each of the dimensions. So 4 deep, 5 wide, and 10 high. So 4 times 5 is 20, times 10 is 200. So the answer is 200 matchboxes will fit into the carton. 1 mark for 200 and the 2 marks for showing out a process for working out how many fit into the carton. Question 16. Here we've got a diagram with various angles marked on and various sides of lengths. So it's telling us that ABC is in a straight line. AB is equal to BD. So this length here is the same as this length here, which will make this triangle ABD back to a isosceles triangle. So if that's 25 degrees on an isosceles triangle, this must be 25 degrees. Now we've got to work out the size of the angle marked X and give you the reasons for your answer. Okay, so if we know it's an isosceles triangle and the 2 angles are 25 at the bottom, the angles in a triangle add up to 180. Therefore, if we take the two 25s off, we end up with 130 degrees for this angle here. Because ABC is on a straight line, if this is 130, that makes this angle here 50 degrees. Again, the angles in a triangle are 180 degrees, and we know one of the angles is 50 and the other angle is 70. So if we take 120 away from our 180, it tells us that x is equal to 60 degrees. So the marks, 1 mark for getting 60 degrees for x, and probably 1 mark each for working out the other 3 angles within the shape. Question 17. The table gives information about the results of the matches of a football team that have played. They've either won, drawn or lost games. Draw an accurate pie chart to show this information. Well, when you're drawing a pie chart, you're dealing with 360 degrees, and whatever you've got has to go into the 360 degrees. So first of all, you need to add all of the things that are going into the pie chart. So 28 plus 12 plus 20. So 8 and 2 is 10, 1, 0, 2, 4, 5, 6. So we have a count of 60 that we need to fit into our 360. So 360 divided by 60 tells us each item is worth 6 degrees. So we need to go back to our frequency table and multiply each of our frequencies by 6 to work out the angle we need to plot for won, drawn and lost. So let's start with 1. 28 times 6. So 6 8s are 48. Put down the 8, carry the 4. 6 2s are 12, plus the 4 is 16. So that's an angle of 168 degrees we need to plot for 1. Let's look at drawn. 12 times 6, you should know this from your 12 times tables, 72. So we need an angle of 72 degrees. And this one, 20 times 6, is 120 degrees. So they're the 3 angles we need to plot. And as a check, you can add them together and you get 360 degrees. So that's a double check that you've done your calculations correctly. So now we get a protractor and we plot our angles. Place the crosshairs of the protractor on the center of your circle and then line up the reference line they've given you with 0. So to plot our first angle for 1, we need to go round 168 degrees. So starting with 0 here, read round 168 and put a little marker where 168 is. Move your protractor away and draw a straight line from the center of the circle to where your marker is. And I would annotate the pie chart with 168 degrees and put in the word 1, and that's what that piece of the pie chart represents. Now the easiest way to plot the next one is to line up the 0 marker on your protractor with the line that you've just drawn. So again, the crosshairs go into the center of the circle and rotate the protractor around until 0 is lined up with the line that you've just drawn. So now it's easy to plot the 72 degrees. So starting at 0 here, count round to 71, 2 degrees. Put a little mark where 72 degrees is. Again, remove the protractor and draw a straight line from the center to the mark that you've just made. Again, annotate the angle to show the examiner you've measured it, 72 degrees, and write down what this piece of the pie chart represents. And that should leave 120 degrees as the final piece, and write down what it represents. The final thing with a pie chart is I would probably give it a title. And that's the pie chart. Question 18. X is equal to -5 and y is equal to 2. Work out the value of 3x plus 4y. So in longhand, it's 3 times whatever the value of x is, plus 4 times whatever the value of y. So now in longhand, I put in -5 and I add 4 times 2. So 3 times -5 is -15, a positive times a negative, plus 4 times 2 is 8. So think about your number line when you get negative numbers. I'm starting at -15 and I'm adding, so I'm going in that direction, 8. So that takes me to -7. Janet buys P packets of sweets. There are 10 sweets in each packet. Write an expression in terms of P for the total number of sweets Janet buys. So an expression is a term or terms connected with a plus or a minus. And the giveaway for an expression is that there's no equal signs. So 10 sweets in each packet, but we don't know how many packets. So that would be 10 times P, or 10P for our expression. Janet eats 7 of the sweets. Write down an expression in terms of P for the number of sweets Janet now has. So if she had a total of 10P, we're going to take away the 7 that she ate. So 10P minus 7. So 2 marks available, 1 for the first part and 1 for the second. Question 19. Work out 3/5 minus 1/3. Well, you should be able to identify that you cannot take away apples from bananas. They're totally different things. And what we need to use is equivalence. Equivalence is the secret to adding, subtracting, comparing, and splitting fractions. So let's make them equivalent. What we're looking for is a denominator that both 5 and 3 have in common. And the easiest way to do this is multiply 5 by 3. So they both have the number 15 in common. Now, because I've gone from 5 to 15, I've multiplied it by 3. So what I do to the denominator, I need to do to the numerator. So when I multiply 3 by 3, I have 9/15. So 9/15 is exactly the same amount as 3/5. It's just written in a different way. That's what we call equivalence. Now let's look at the 1/3. To get from a denominator of 3 to 15, I multiplied it by 5. So I need to do the same to my numerator to make sure it remains equivalent. So 1 times 5 gives me 5. So 1/3 is exactly the same amount as 5/15. It's just written in a different way. So now we have the same denominators, I can do the subtraction. I have 9 and I take away 5, so I have 4. And because they have the same denominator remains. So the answer to 3/5 minus 1/3 is 4/15. And that's what you would put on your answer line, 4/15. Question 20. 50 people each did one activity at a sports centre. Some went swimming, some played squash, and others went to the gym. 21 people were female, 6 of the 8 people who played squash were male, 18 people used the gym, 9 males went to swimming. Work out the number of females who used the gym. One of the best ways to address this problem is to draw up a table of all the activities and put in the information that we know to find out the information we don't know. So people either went swimming, played squash, or went to the gym. And these people were either male or female. So you'll have a total for the number that went swimming, played squash, or to the gym, and we'll have a total for males and females, and the total overall for the people who went to the gym. So we know at the start there are 50 people in total. 21 of the people that went were females. So 50 minus the 21 tells us there were 29 males in total. 6 of the 8 people who played squash were male. So 6 of the people who played squash were male, which means 2 were female, and there were 8 in total. 18 people used the gym, so there were 18 people that used the gym. 9 males went swimming, so 9 males went swimming. So this will tell us how many males went to the gym. So if there were 9 plus 6 males going swimming and doing squash, that's 15. And we know there's 29 males in total. 29 minus the 15 tells us that 14 males went to the gym. Now we can start filling in the blanks. If 14 males went to the gym, 4 women went to the gym to give us our total of 18. So it asks us to work out the number of females who used the gym, and from this information we can put down 4. If you wanted to, you could fill in the missing information. So for completeness, if we wanted to, we could complete the table and fill in the missing information, but the question doesn't ask for it. Our 4 marks, 1 mark for 4 and another mark for doing the calculations that lead to this answer. But let's complete the table. We know that 21 females went to the sports centre, 4 went to the gym, and another 2 played squash. So 21 minus 4 is 17, minus another 2 is 15. So we know 15 women went swimming. The total for swimming, 9 plus 15, gives us 24 people in total went swimming. And when we add 24 to the 8 to the 18, that also gives us our 50 of total of people that went to the sports centre. Question 21. Mr. Brown and his 2 children are going to London by train. An adult ticket costs £24, a child ticket costs £12. Mr. Brown has a family rail card, and the family rail card gives 1/3 off adult tickets and 60% off child tickets. Work out the total cost of the tickets when Mr. Brown uses his family rail card. Okay, so let's do the adult first. For the adult ticket, it's normally £24. However, we get 1/3 off. So to work out 1/3 of 24, divide it by 3. So 24 divided by 3 is 8. So it's 1/3 off it. So £24, take away 8, means the adult ticket that he's going to buy is £16. Let's look at the child tickets. The child tickets are normally £12. However, we can take 60% off a child ticket. So let's work out 60% of our £12. So let's start by using our 10% rule. So 10% of £12 would be £1.20. So to get 60%, we need to multiply £1.20 by 6. So let's do that over here. Well, we don't like multiplying decimals, so let's get rid of the decimal point and move it one place to the right. And that will give us 12 times 6 is 72. Remembering to move your decimal place back one place, £1.20 times 6 would give us £7.20. Now it's £7.20 off the £12. So I've got £12 and I'm going to take away £7.20. So 20 pence away from this means we have 80 pence here. £7 from 11 would give us 4. So the price of one child ticket is now, with the rail card, £4.80. And we have 2 children, so we need to multiply that by 2. So that's £9.60. The price of the adult ticket is £16. The price of the 2 children tickets is £9.60. And so when we add them together now, we have £25.60 as the price for all of the tickets, which include the discount. So £25.60 for 1 mark for calculating the adult price correctly, and 2 marks for calculating 60% off and the fact that there are 2 children. Question 22. Rebecca wants to find out how many books people buy. She's going to use a questionnaire. Design a suitable question for Rebecca to use in her questionnaire. So an obvious question would be, how many books do you buy every month? And then we could put a tick box so that people can tick the appropriate amount. So 0 to 2 books, 3 to 5 books, 6 to 10 books, and more than 10. Now it's important that your selections don't overlap and that you have sensible amounts to give you the information that you need for whatever you're going to use the data for. Question 23, and a bit more algebra. Part A wants us to expand 2m brackets m plus 3. So when you expand brackets, whatever's on the outside multiplies each of the terms on the inside. So 2m times m is 2m squared. 2m times 3 is 6m. So when we put them back together, we have 2m squared plus 6m. Part B. Factorize fully 3xy squared minus 6xy. So the key to factorizing is pull out things that are common to each of the terms. So for example, the number 3 is common to both 3 and 6, so we can use that. The letter x appears in both terms, so we can pull out the x. And then finally, the letter y appears in both terms, so we can pull out a y. So 3xy is common to each of the 2 terms that we're looking at to factorize. So if that's on the outside of our brackets, that's what factorizing is, then we have to ask ourselves, what do I multiply 3xy by to get 3xy squared? Well, I've already got the 3 and the x, so what do I multiply y by to get y squared? Well, I multiply it by y. Put in your minus sign and then ask yourself, I have 3xy, but I want 6xy. So I have the x and the y, but how do I get from 3 to 6? Well, I multiply it by 2. So that is the second part of our factorization. So for our 2 marks, 3xy brackets y minus 2, where each of the terms inside the brackets is worth 1 mark. Question 24 shows a diagram of a plan of a small field. And Kevin is going to keep some pigs in this field. Each pig needs 36 square meters of space. So work out the greatest number of pigs Kevin can keep in the field. So we need to work out the area of the field and then divide it by the 36 square meters to work out how many pigs we can fit into it. Now, to work out the area of the field, we can do this in one of 2 ways. Because it's a complicated shape, we break it down into 2 simple shapes. So we can either break it down into this rectangle here and this rectangle here, or we can break it down in this direction and have this rectangle, which is 10 meters by 7, which gives us 70 square meters for this area. And then this area is 6 meters high, and then the width, you have to be careful. If we know it's 7 from here to here, from the bottom, then we know that whatever's left is 16 minus 7, which gives us 9 meters. So the area of this part of the field is 9 times 6, which is 54 meters squared. So the total area of our field, our complicated shape, is 54 plus the 70. (124 meters squared). So that's the first part of the question and probably worth 1 mark each. Now what we need to do is work out how many 36s, our 36 square meters, go into our 124. So it's 124 divided by 36. Which doesn't look particularly easy. So how can we do this? Well, you can do it by long division, or you can do it by your 36 times tables. So just write 36 and then add another 36. So do it longhand if you need to. So 36 add 36 is 72, and then add another 36 is 108. And add another 36 is 144. Now that's all I need to do, because 144 is too big and 108 goes into our 124 3 times. So 124 divided by 36 goes in 3 times with some kind of remainder. Okay, and the remainder is 16. We're not particularly interested in that. So he can keep 3 pigs in this field. And that's the answer to the question. Notice it's got the asterisk. So in English, you can put down Kevin can keep 3 pigs in the field. Question 25 is about rotation, and we need to rotate the object A 180 degrees about the point 11. So let's mark the point 11. This is the center of our rotation. Now, because it's 180 degrees, it doesn't matter if you go clockwise or anti-clockwise, you will end up at the same place. To do rotation questions in the exam, we advise you to use tracing paper, and on the tracing paper, draw the shape. Then, with your pen stuck in the center of the rotation, rotate the shape about the center of rotation 180 degrees. And your shape will end up in this position. For accuracy, the shape that you've rotated to its new position is called the image, and in theory you should annotate it A dashed. So when you rotate A 180 degrees about 1, 1, A dashed is where it ends up. Final question, question 26. 4 pints of milk cost £1.18 and 6 pints cost £1.74. Which bottle of milk is the best value for money? Show your working out. So again, this is to do with ratios where we have a number of pints against a cost. So we have 4 pints costs £1.18. And if I want to know what 1 pint costs, then I have to divide it by 4. What I do to one side, I do to the other. So 1.18 divided by 4 will tell me how much 1 pint of milk costs for the 4 pint bottle. So 4 doesn't divide into 1, carry the 1. 4 goes into 11, twice, remainder 3. 4 goes into 38, 9 times, remainder 2. 4 goes into 20, 5 times. So when I divide 1.18 by 4, I get 0.295 of a pound, or 29.5 pence. Let's look at the 6 pint container. So we've got the number of pints is 6, and the cost of 6 pints is £1.74. So to work out the cost of 1 pint, I have to divide 6 by 6 to give me that one. Because I've divided that by 6, I divide the cost by 6. So we need to divide 1.74 by 6. So 6 into 1 doesn't go, put the decimal point and carry the 1. 6 goes into 17 twice, so 6 twos are 12, so that's a remainder of 5. 6 goes into 54 exactly 9 times. So 0.29 of a pound, or 29 pence exactly for the 6 pint bottle of milk. So which bottle is the best value for money? Again, it's got an asterisk, so it wants a written answer. You can say the 6 pint bottle is better value. That concludes the questions for this exam paper. This has been an Archie the Pooch production, and I hope it has been of some use to you. If there's anything within the video that you're unsure of, please don't hesitate to get in touch with me, and I'll see you in class. Goodbye.